Hello everyone. Welcome to another episode of my YouTube channel, Data Science with Sam. This vlog is a continuation of the learning series that I started a few weeks back. If you watched my previous vlog, you already got to know about one of the very essential unsupervised learning techniques called hierarchical clustering. In that video, I covered the main essence of hierarchical clustering, how these clustering techniques comprised of two algorithms such as agglomerative and divisive. Now you know that which particular algorithm you should apply for your clustering work. I also covered a description of 4 similarity measures that we use to understand the correlation between data points and then perform clustering accordingly. If you haven't watched that video, I'll definitely recommend you to go back to my YouTube channel and watch that vlog, because it's very important for you to understand the basic concept of hierarchical clustering before you start coding on it. Like in today's vlog, I'll show you an R code example of hierarchical clustering applied on a very famous data set. So let's get started and see how you can write your first R code to perform hierarchical clustering on a very famous IRIS dataset. For this particular exercise, I'm going to use the IRIS dataset. IRIS dataset comprised of like 4 numerical columns and 1 categorical column. So the 4 numerical columns denotes the length, width of sepal and petal. So I'm going to use any of those columns to form the distance matrix of the data points and then apply the hierarchical clustering based on that matrix. Because when you are trying to form a cluster, you always try to understand the similarity between 2 data points. And if those data points are similar based on their numerical value, then you form a cluster with those 2 data points. So it's very important for us to apply the hierarchical clustering on numerical values. You cannot actually apply hierarchical clustering on categorical column. So I'm going to use hclust function from our stats package to form the hierarchical cluster. So let's run this code. Now you can see it's actually formed a very nice little cluster, hierarchical cluster in a dendrogram format. So in the dendrogram, you can see they have like 6 different labels. So usually we look for a cutoff level where if you just cut the trees in that level, then it will form a minimum level number of clusters, which will accurately represent the distribution of the data set. Like for here, if I'm going to actually use the cutoff number 3, so I'm going to actually cut the tree branch over here. So what will happen, it will form the cluster equivalent to the number of categories of species with here. So like suppose if I run this code based on the cluster cut variable, what it does that it will actually take all the data point based on the cutoff numbers, and then after that it will form 3 clusters. Since I used a cutoff as 3, that's why we're forming 3 clusters, and each clusters correspond to 1 species. So now in some cases we can increase the cutoff number to get more clusters if we have to dig down more. It's like suppose for here the versicolor seems to be like the biggest cluster. It has a lot of data points, but in some cases you can see these datas are kind of like little dispersed. Okay, they're not forming a cluster perfectly. So in that case you may think of like going down to a just going a little up in the dendrogram level. So in that case, suppose if I select number 4, so what it does, it actually forms 4 cluster now since I raised the cutoff level. So now if you run the code again, you will see that okay, so you'll see that the versicolor, the cluster divided into 2 clusters. So here some of the data points are a little dispersed, so it seems like they're not exactly part of the versicolor cluster per the last plot. So now those data points kind of formed a different cluster, and the color code actually represent the how the clusters are kind of not correlated to each other. So that's how you can, it's up to you that how many clusters you want to form. If you think that the original clusters are not accurately representing the nature of the data points, if you see some data points are dispersed in within a one same cluster, then in that case you can go down to or go up to the other level. You can increase the cutoff and create more clusters accordingly. Okay, so here for the first h-classed function, I use the linkage method complete, but you can also try a different linkage method such as average and single. In my previous video, I talked about this linkage method, which also called as similarity measures. So you can go back to my YouTube channel and watch that video to get an understanding of the similarity measure or linkage method. Also there, you can actually apply some different libraries to get a nice little nice looking, dendrogram like this one. If you run this particular code, you'll get a different looking like dendrogram with a different color code. So it's not coming correctly at this moment because of some resolution issue, but I'll definitely recommend you to check the comment section, the caption of the video, because there I would copy paste the link of the GitHub source code. Okay, so I would recommend you to just go to my GitHub account and try this code on your end. Okay, so just export the code and run on your RStudio environment. Then you will be able to see that different histogram and the dendrograms. You can also create some heat maps. Like in some cases, we may have to perform a correlation matrix to find out that how the data points are correlated to each other. So in that case, you can actually create, you can actually just run this code to create a heat map and see that how that heat map is correlated with the dendrograms or the hierarchical cluster. Like here, you can see this sepal length. As per the heat map, the sepal length is more dense. It's because it's possible that the sepal length has more data points, it has more numerical value. So in my previous h-class function, I used petal length and petal width from the distance matrix. So maybe it'll be a good try to check out that if you switch to sepal length and sepal width, it can be get a better matrix, a better cluster. So sometimes you actually have to switch around the different attributes or the features to find out which columns will be attributing more to forming a better cluster. So in that case, this heat map concept is pretty good. So you can actually run the you can actually first build the heat map first to understand the distribution of data points in various columns. And if you see a particular column has like a more dense heat map and more data points existed in that particular column, then you can use that column to build hierarchical cluster. So heat map is, I would say, as a very good prerequisite to understand the distribution of the data points and use those columns for building any future cluster. So that's all for now. Okay, as I said, I'll definitely put the GitHub source code link in the caption section. I'll recommend you to just to export the code and just run it in your RStudio environment. So let's go to the conclusion section to wrap up this video. So that's all for today. Hopefully this video gave you a notion of how we can perform hierarchical clustering using R programming language. I definitely recommend you to go to my GitHub account, download the code, and then try it in your RStudio environment. I'll also recommend you to try different linkage method, because I only showed you that complete linkage method. Maybe you can apply single or average similarity measure or linkage method to see if you can get a better cluster, or if you can form better dendrograms, and then apply the cutoff accordingly. I'll also recommend you to try that heat map code, because sometimes it's very important to understand the correlation between all the data points on the columns before you apply the hierarchical clustering. So in my next video, I'll talk about another important clustering techniques called k-means clustering. So stay tuned for that. And also, please don't forget to like and subscribe to my channel, because I'll share more contents and vlog based on data science, unsupervised learning, and machine learning. And also feel free to share my vlogs with your friends and professional contacts, because data science is the main essence of anything right now. And unsupervised learning is very important, because if you can't perform unsupervised learning, you will be able to excel in different areas such as like healthcare, science, and the other research area where we don't actually have data points with specific labels. So stay tuned for the next video on k-means clustering, and don't forget to like and subscribe to my channel. Until then, goodbye.